Hi, it's Jerry, and we're back with another C Sharp training. We're back with some mathematical operations, and yeah, sorry about that. Yeah, first of all, before we jump into some more complex operations, I wanted to show you some simplified operations from like addition, subtraction, multiplication, and division, which are called like simplified assignment operations or something like that. Well, you can find them in the reference. So we had these. It's called compound assignment. Yeah. So these operations are like this: these, and these. Well, yeah. The other ones are also compound assignment operations, but um, they do different stuff, and we just want the basic mathematical ones. So, um, whenever we want to do something simple, like we have our result, and let me just comment this for a second. Yep, and then we'll get these out here somewhere. Okay, so now, yeah. Okay, now our result is just equal to a, so we're assigning a value, the value of a, right? It is pretty normal. I mean, you can either assign a value that is arbitrary, so like, well, something, and yeah, let's just make this one a double because I don't like writing the f, and that's why usually I just don't need to worry about memory. So I usually don't use float if I don't have to. I use a double so that I can assign it a value without any letters on it, and just convenient for me, right? So yeah, you can assign an arbitrary value, or you can assign a value of another variable, right? So that's pretty obvious, and then we can use those compound assignment operations, and what these do is okay, let me first just show you that. So we can say like the compound addition assignment, and then just say B. What it does is actually, this means that I want to assign to this variable on the left the result of adding this variable and the variable on the right side, or the expression on the right side actually. Because here we could say like B plus B, right? Well, let's just make it a bit more simple. So this is the same as if I wrote result is equal to result plus B, right? This is the same, right? So uh, the same as if I wrote this. And then I'll say compound addition, right? Okay, so compound addition, and we can see that A is equal to 2, B is equal to 3, compound addition is equal to 5. And maybe let's add also one more thing here. This, and is equal to. Okay, yeah, so that's a bit more. Uh, so we have the result equal to 2, right? And then we perform the compound addition, and it's just the same as if I would say result plus b. So result 2 plus b, that's 3, and then we're assigning that back into the result, and then printing it out, and the results in 5, right? So we can do this compound addition, we can do this compound multiplication as well, right? So this would be the same as writing result times b, right? So like this. So that's 2 times 3, and that's 6, right? Let's try the subtraction as well, right? So minus equal b, and that's -1. And now the division, let's see what that results in. And should I use this one or the other one? Let me see. Yeah, I'm using the right one. Okay, let's see what it does. Yeah, it works great. And you know why? Because result is of type double at the moment. So we have the double value here. Even though I assigned a, which is an int, into the result, but then this result holds a float and it can't change its type because we declared it a double. So we just assigned it a value of a, right? So we just put 2 inside, and this 2 is now of type float. And then if we perform the division, then the result is okay, right? So that's the, well, we should say compound division, but well, maybe at the end of this video I'll just put all those inside. But I just want to make this a bit faster. Maybe we'll increase the speed of those trainings so that we can learn a bit more. Okay, so this is one of those operations that you can perform. And now another one I want to show you as well is those postfix and postfix addition and subtraction, and then prefix and prefix addition and prefix subtraction. So these two, and there are 2 minuses here. It's hard to show. Okay, 1 minus and another one, right? So the 2 minuses here, and then the 2 pluses here, right? So I want to show you these two as well. So maybe let's show it like this. So I'll comment these two here, right? So we'll have this result printed out. So now we just have the result equal to 2 because a was equal to 2. And now we'll first use the prefix operation. So we'll just say plus plus a. And what it does is increases the value of the expression on the right. So it increases the value of the expression on the right, and does this before any other evaluations. What it says here is the prefix is right to left, and that is something that I told you that, okay, it might be obvious for you when you see that. Currently it's not that much obvious, but first it performs all the actions on the right and then increases the value, and that value is then returned. So the value is already increased when this happens. So let's see this in action. So we assign the value 2 to a, and then we increase the value and then assign it to the result, which then gets us 3, right? Now let's do this the other way around. So we will have this, this was a prefix, then we'll have a postfix, right? So plus plus at the end. Now if we see the result here, now the result is actually 2, because what we do here is, and let's find this one. Yep, okay. This one is left to right. So first we perform this operation. Unfortunately then, well, yeah, maybe this is not the best example, but actually then the assignment goes, and at the end we increase the value, and that's how it goes. And I don't think you'll get to know that just straight out of reading this table, but that's what happens, you know. So the assignment goes first, and then this the value here gets increased, right? So that's what happens. Yeah. Okay, and now I said this prefix that it evaluates the thing on the right hand side first. So let's just stop this program and have this prefix here. So we'll have plus plus, and then we'll have A plus B. Oh, I can't do that. Oh, that sucks. Okay, yeah, because it also does the increase here. So yeah, so we can only do that with a single variable. So yeah, so this is actually really simple. I thought maybe I could show you this left to right and right to left, but okay. So both of these increase the value, right? One does it before any other operations are done, and the second one is actually done after all the operations are done, right? So if we would go here and say, like, again, print out the value of A and the value of B, right? Then you would see that, okay, we assigned the value of 2 to A, we assigned the value of 3 to B, then we have the result assigned the value of A, which is 2. A is then increased, and then the result is A being equal 3. Okay? So this is something that is really, really important to remember, that this operation is being performed after the evaluation of the whole expression. Okay? So this is quite important. I hope you understand that. If you don't, I don't know, please leave a comment, or I don't know, send me a message. Yeah. Okay, so I hope this is a bit understandable for you. And of course, we can do the same thing. So we can say minus minus A. So the prefix. So we are assigning. We first evaluate the decrease by 1, right? And then we assign it to the result. So the result is 1, and then A is 1. And then if we use the postfix, right, so minus minus here, then the result gets the value of 2, which was the original value of A, and then we get the value of A being decreased by 1 and printed out on the screen. Okay, and this is something different than in other programming languages, because I think not all of them allowed this operator to be performed on floating point numbers. I'm not sure what's the result of that, but let's say we get the result plus equal to 0.5, so that we have something like this. And then I'm going to do result minus minus. This is an expression, and it's also a statement. So it should reduce, I'm sorry, just a little cough. My throat is getting worse. So this should reduce the result by 1, and we should see that there. So let's see how it looks like now. Okay, so A is equal to 2. Then we have 2 being assigned to the result, because we have the postfix reduction by 1. Then we add a half to the result, so that's 2. I'm sorry, 2.5. And then we reduce the result by 1 using the postfix operation. So this is evaluated, and then the next statement, in the next statement, the result is already reduced by 1. So won't matter if we do the prefix with this or the postfix. So that's why we get the 1.5 value here. And I'll just going to show you. So if we do minus minus here, we'll get the same result, right? And okay, this is something I'm curious if it is possible to do something like this, because I saw this and no, it's not possible. And I was like curious, okay, maybe I can do that. But actually, I think, no, I can't. If I put brackets here and didn't work earlier, because, yeah, because this is an expression and you can't set a value to an expression. Okay, so yeah, so you can't do this, but you can just have this variable with a prefix and postfix operators, and this is for addition. So yeah, we have this postfix plus plus, postfix minus minus, and we have the prefix plus plus and prefix minus minus. There are some other ones, right? But you don't have the prefix and postfix multiplication and prefix postfix division, because these actually mean like this. Maybe because yeah, this is like as if you would go result minus equal 1, right? Or result plus equal 1, right? Something like this. And then it would be like this could mean something like this: result times equal 1, which just doesn't make sense because it's just the same, so there's no sense. And then divide equal by 1 is still doesn't make sense because it's still result, so it doesn't change anything, and that's why probably the language doesn't have this definition. So if you're curious, why don't we have this multiply and divide? Because it would be just by 1, because it's always by 1. With this, how do they call it again? Compound assignment. No, it's just a postfix and prefix. Well, addition is subtraction. Yeah. Okay, so these were the basic mathematical operations. As I said, I'll organize the code, but I just want to go a bit faster with this. So we'll have these A and B. We'll keep these. We'll have the result, and I'll maybe just comment this so I get to know what I was doing here, and I'll try to create a file with all the things that we did in this later on, and then add it to the video. So now you might think like, okay, what if I want to raise something to a power, or take a square root of something, or other root, like the root of order 3. I think that's what it's called, or and so on and so on. So yeah, there are no such simple operators like okay, addition, subtraction. In some mathematical tools, I think Excel has it. Well, we can check. I have Excel here. Let's see. Yep, here is Excel. Yep, and then you can say like 2 and 3, and then you can say 2 to the power of 3. Yep, so 2 to the power of 3 is 8. Yeah, you can say that. Now, unfortunately, in C#, if you say result is equal to a to the power, let's think it might be the power of b, and it is a mathematical operator, but if you look it up here, it's actually something else. It's a bitwise exclusive OR. So it's a XOR. Yeah. So it's an XOR operation, which means like either this or that. Right? Yeah. We'll play around with some logical operators in a second. But okay, here the result would be just 1, which is not true because we know it's 8, right? So okay, so how to raise it to a power? Well, there is another tool called math, and it's also in the system namespace. Yeah, so in our system toolbox there is this math class, or Well, let's see the definition of that. We can hit F12, and yes, it's a class. And then if I hit F12, I can see everything that is defined there. Yeah, and there is another one. If you hit F1 here, you'll be moved to this MSDN reference. If your Visual Studio is configured so that it actually goes to that reference. If you hit F1, it should ask you whether you want to go to online reference or use some internal reference, which might be out of date. And this one is actually changed a lot, and then you can get to know more information about what's the thing you checked. And they have lots of examples so that you can get to know what's there, right? Okay, but the math class contains a lot of cool methods. It's something like in Excel, so you have those functions, mathematical functions, right? And one of them is POW, short for power, right? And then it takes two variables, and we'll be talking about methods and functions later on. Maybe on the next video. I'll think. Yeah. So, well, this method takes two variables, and you have the description below. So first one. So let's just insert one because x. Yeah, x is the double precision floating point number to be raised to a power. So we want it to be a raised to the power of b, right? So 2 to the power of 3. So first we'll pass a, right? And I don't think you might see this, but there is a comma here, right? So we need to put that comma here. And then we have the y, and that's a double precision floating point number that specifies a power, right? So we want this to be power of 3. Okay, so we want this to be b. And now if we run the code, we get 8, which is actually the correct result, as we could see that in our Excel file here. Yep. Okay, so yeah, that's raising to a power. Now, I also said we would probably like to have the square root or any root. So let's just see, like, okay, we want to raise a to the power of 2, which is 4. And then we'll take the square root of that and put that in the result. So result is equal to, oh, and wait. We'll put that here, so we'll double this line, and we can comment this one out. Yay! Cool. Okay, so we have this, and now we want to assign to the result the value of math, and then there's this function that's called sqrt, which means, well, it's short for square root, and it takes the square root of a specified value, right? So d here is the double number, the number whose square root is to be found, right? So we want to take the square root of the result, which will be 4 at this particular moment. And then if we do that, then we can see, okay, so a raised to the power of 2, so 2 raised to the power of 2 is 4, 2 times 2 is 4, and then the square root of 4 is 2. Now we can make something a bit more complicated. Let's say we want the square root of 3. Yeah. It's something like this. So you can actually create a simple calculator that actually performs those operations. Almost. I mean, well, it will be really simple because those calculations will be done by you entering the numbers in code at the moment, but we'll create that calculator soon as well, because, well, I have that in plans. Okay, so that's the square root. Okay, what if you wanted to have root of order something? Well, I'm not sure. Maybe I'll check that in a moment. But I came to an idea. So let's guess. Okay, square root of 9 is 3, right? Very good. And then root of order 3 of 27 should be 3 as well. Well, when we take the square root of that, it's just 5 point something, right? So we want the root of order root of order 3. And now let's see if math has like root, no root here. So, oh, and there's just only SQRT. But if you know math a bit, then you know that the root operation is actually the reverse operation of the power. And let me write that quick maybe. I'll do it. I'll try to do it. Just wait. Okay, I got it. Had to use Microsoft equation. So the root of order 3 of any number is actually this number raised to the power of 1 over that order, right? So we'll try to do that now in C sharp. Well, I'm not sure if you'll actually need that anytime, but well, okay. So we have 27. Let's just comment this out for now, so we have this cleared. Okay, and now we have to do the 1 over 3, right? So this part, yeah, this part, right? And if we do something like this, I did it for the first time, and I was like, huh? What? It doesn't work. Yeah, because it doesn't. Why? Because 1 over 3, the result of that is an int, which is 0. And anything to the power of 0 is just 1, right? So we need to make it float or double or well, something, so something more precise, right? And then if we do it like this, and hooray, hooray, we have the result equal to 3. So the root of order 3 out of 27 is 3. Okay, so now you have, I think, some more complex tools to play around, and I encourage you to actually explore the math library. So it's not a math tool, right? Math, and then just try to use some of these functions here, methods, right? I told you I'm going to mix those because, well, it's convenient, right? Yeah, try to use them and have fun with it. Let's wrap up this video. As I said, I'll try to organize this file so that you get some more examples here or all the examples that I used in this video, and then I'll try to maybe attach it somewhere to the video. Thanks for watching and have a good day. See ya.